Morning, man. I'm gonna start with 4.2445 graphing a logarithm function. All right, the simplest one here: graph f of x equals log base 2 of x. All right. Well, what does that mean? Okay, so let's rewrite it as y. This will help us understand it. Y. I'll be down right here. Rewrite it as y equals log base 2 of x. Okay, and then let's rewrite it as an exponential function. All right, there's our base 2. Base 2. There's my exponent, right? Logarithm is exponent, and we'll do this. X equals 2 to the y power. Okay, and we got our y-axis and our x-axis. Okay, so we can substitute in some values. So it's easier to go from f of x to see what you're doing. So the easiest one, of course, we always love to start with 0 for y, right? F of x is the same as y. 2 to the 0 power, x is 1. Okay, 1 comma 0. That's our first point. Okay, let's substitute a 1 here. 1 for y, 1. 2 to the first power is 2. 2 comma 1. Okay, then it's going to go, you're seeing this exponential thing, right? So if I put in a 2 for the y, 2 squared, 4. 4 comma 2. 4 comma 2. Alright, now I'm going to put in a 3, of course. 3 for y, 2 to the third power. 3 for y, 2 to the third power, 8. Oh, okay, it's increasing really fast. So let's see. We're going to have 8 comma 3. 1, 2, 3, 4, 5, 6, 7, 8 comma 3. Okay, so we can see what that's happening there. It reminds you so much of that exponential, right? Because it is an exponential. We've just turned it sideways and flipped it over. We'll talk more about that turning sideways and flipping over thing and how it's an inverse function next time. But let's just get an idea about graphing these, moving them around, get comfortable with them, then talk about the exponential thing. So let's go with a negative here, huh? 2, let's see, x equals 2 to the negative 1. If I choose a negative 1 for y, right? Put in a negative 1 here. Well, I'd flip this over, be 1/2. So I got 1/2 comma negative 1. And then I'll have, let's try negative 2. 2 to the negative 2, x. So negative 2 here. And we'll flip it over and 1/4. Okay, we see what's happening, right? We had 1, 2, 4, 8. Now we're going to have 1/2, 1/4, 1/8, 1/16, 1/32. Right? It's going to get closer and closer. So what was this one? Negative 2, 1/4, negative 3, 1/8, 1/16. It's going to get really close. So think about domain. Okay, there's a couple questions about domain and range later on. This one, you just identify that graph, okay? So it doesn't matter what your base is so much on this problem, 4.2.45. If you want to do this graphing thing, that'd be a fantastic exercise because it's a real head scratcher. But they all look like this. This is your basic logarithm function. That's how it basically looks, okay? And if you want to flip this over and put your x-axis here and your y-axis here, then you would have an exponential function, right? Because you can see we've graphed the exponential function y equals 2 to the x, right? We've graphed that, and we know what that looks like. Now we're graphing switching the x and the y. Okay, let me erase that so it doesn't, if you're looking at the freeze frame, it doesn't screw you up. But all right, so there's your basic logarithm function.